Students, welcome to your favorite channel Science with Mukherjee sir. Myself K.K. Mukherjee. Today we are going to discuss a very important thing in the classification of elements and the periodicity in the properties chapter. In this video we will going to discuss how you can able to identify the location of the elements in a periodic table when you have been given the atomic number. From the atomic number you have to identify the periods as well as the groups of this element in the periodic table. First we will understand how we can able to identify the elements in the period of the periodic table. So first let us understand. So let us write down to identify the elements in the period. To identify the elements in the period of the periodic table. For that there is a very simple rule that you can see, that is period number. Whether the element is the number 1 period, number 2 period or number 3 period. So this is basically we can say a period number. This period number is basically equal to the number of the valence cell. Okay, number of the valence cell. Valence cell means, that is number of the valence cell means, that is the n, means the quantum number of the valence cell. So if we know the quantum number of the valence cell of this element, we can able to say in which period this element will stand. So for that, let us take one example that will give us very clarity about the identification of the elements from its period. Suppose you have been given a atomic number. Atomic number is given, that is 21, suppose. And from this atomic number you have to understand, you have to tell in which period this element belongs. For that, what we have to do? To know the number of the valence cell, that is the principal quantum number of the valence cell, you have to write the electronic configuration. So what will be the electronic configuration of this element? Having this 21 atomic number, this will be 1s2, 2s2, 2p6, 3s2, 3p6, then 3d1, 4s2. Okay, see the number of electrons, that is 10, 12, 18 and 21. So total 21 electrons is there, and this is the electronic configuration of this element. So what will be its period? We know the period number is number of valence cell. What is the number of valence cell? Number of valence cell is 4. So if 4 is the number of valence cell, then we can say it is a period number is 4. Period number is 4. That means this element belongs to the 4th period of the periodic table. Okay, so this is a very easy thing. If you write the electronic configuration very correctly, then you can able to say the correct period number, periods in which this element belongs. Now the second thing that is important again, because you know when we want to tell about the position of the elements, that will basically its period, and another thing that you have to say, that is the group. So to identify the group now, okay, to identify the group, what will be the group of this element? For that, they are basically, for the S block element, P block element, D block element and F block element, there are specific rules that we have to remember. Number one, that is your, for the S block element, for S block element. S block element, that is a general rule, is the group number. For S block element, group number is equal to your number of electron in the valence, number of electron in the outermost S orbital, outermost S subshell. The number of electrons in the outermost S subshell, that will give the group number of the S block element. Number of electrons, electrons in the outermost S subshell is its group number. So let us take an example of the S block element. Suppose this is 12, right? Without consulting the periodic table, you have to tell in which period, which group, period that is already identified, in which group this element belongs. For that, you have to write down the electronic configuration. The electronic configuration 1s2, then 2s2, 2p6, 3s2, 3s2. Okay, this is your, and this will be the electronic configuration of this element. And in the outer cell, in the S subshell, you see there is 2 electrons is there. In the S subshell, there is 2 electrons, and that is why the group number, that is elements having the 12th atomic number, will be in the group 2. This is the group 2. Okay. So group number is number of electrons in the outermost subshell. In the outermost subshell is 3s. Here, number of electrons that is being placed here in the 3s subshell, that is 2. That is why the group number of this atomic number, this is basically magnesium, and to having the group in the group, second group of the periodic table. So we understand the S block element, or the S block element group number is equal to the number of electrons in the outermost S subshell. Okay, I think that is understood. It will be very easy to understand. Okay, now we go to the P block element, that D block and A block. For the P block element, you know its outside electronic configuration is ns2 np1 to 6. This is its outside electronic configuration for this P block element. For the P block element, this rule is this: the group number is basically 10 plus number of electron in the valential, number of electron in the valential, that is S and p sub cell. So group number, that is state plus number of electron in the valence cell that is S and P for the p block element, S subcell and P subcell. Let us have some example. Suppose atomic number is 14. For that, you have to always, when you are going to do all this exercise in your examination, that will be 1 or 2 questions normally give. So at that time, first we have to make the electronic configuration 1:2, 2:2, 2p6 and 3:2. Okay, 1:2, 2:2, 2p6 and 10. Okay, so this is the electronic configuration and we have to find out the group number. The group number is basically that we have already understood, that is 10 plus number of electron in the valence shell. Here electron in the valence shell is 2 plus 2. 2 plus 2 means 4, 2 plus 2, that is group number 14. Group number 14 and its atomic number also 14. How that is possible? And yes, it is possible because coincidentally its atomic number and its group number becomes same. So this is how we can do this group number for the p block element, that is 10 plus number of electron in the valence shell. And now we do for the d block element. D block element. D block element, we know its valence shell outside configuration, outside valence shell configuration is n minus p 1 to 10 ns2. For this, group number is basically group number. Group number is given by the number of n minus 1 d electron, n minus 1 d electron plus ns electron. Number of n minus 1 d electron and plus n plus ns, number of ns electron, that will give the group number of d block element. And this is the outside cell electronic configuration. For that, let us understand, suppose this is its atomic number is 24. So its electronic configuration will be 1:2, 2:2, 2p6, 3:2, 3p6, then 3d5, 4s1. So we can see, you count these electrons with the atomic number 4, 10, 12, 18 and 6 is 24. This is chromium. And is, you know, the group number is basically that in the n minus d electron, n minus d here is 3d and n is 4. So total electron 5 plus 1 means 6. So group number here is 6. In the 6th number group, this element positioned. This element table in the group number 6. So you can understand this is the groups. Okay. Now we will understand the last thing, that is the A block element. So now we are going to discuss the for the A block element. A block element is basically, you can see there is a 2 A block element. That is, one is a 4A inner transition element, that is the lanthanoid series. In the lanthanoid series, the total 14 elements start from the selenium, that is 58, to ruthenium, that have been placed with the lanthanum. Its atomic number is 57 in the group number 3 in the period number 6. That is one series of transition element, inner transition element, that is also called the rare earth element. And another, the 5A transition inner transition series, that is actinoid series. Here also you can see the total 14 elements have been placed. That 14 element is atomic number is 90 to 103. 90 is thorium and 103 is lawrencium. And this is in the group 3 in the period number 7. But both the elements has not been the main body of the periodic table. It is been placed in the bottom of the periodic table, and this is how, like this. This is for the A block element. So in this video we learn, that is how we can identify the period. It is basically, period is basically the valential number of the element. That for that we have to write down the electronic configuration first. For the group we can see, that is for the S block, that is number of electrons in the S subshell, that will be its period. For the P block, it is the number of electrons in the valence shell plus 10, that will be the period group number of your P block element. And the D block also, that is basically number of electrons in the n-1 D electron, that is penultimate cell, and this is valence shell, ND valence shell, that is number of electrons in the valence shell. And your flock element, you can see, that is the 14 set of elements have been placed in the same group, but their period is different. For the lanthanoid series, it is the group number 6, and for the actinoid series, it is group number 7. So that is all for today's video. In the next video, we will discuss about different thing in this classification of elements and periodicity properties. If you like this video, you can share to your friends, and hopefully you enjoyed the video. Now that is all, and we will discuss it in that. That is all for today's, and thank you very much for listening.